everybody. I hope you had an awesome fall break and that you enjoyed yourself. We are continuing to talk about community ecology and the relationships amongst the different populations that happen to coincide, cohabitate any given geographic area. These are focusing more on some of the real-time as well as the evolutionary relationships and the adaptations that arise as a result of their cohabitation. Hey, it's the way of the world. It's the cycle of life or the circle of life. Things eat each other, right? And so a community ecologist is going to concern themselves with the whole concept of, well, who's eating who? Food webs and food chains. Um, what types of levels of food webs and food chains are represented in any given community, and is there a robust enough representation on any given level of the food chain to support the level above that? You have your primary producers, and well, it starts with the sun. The sun produces solar energy. Your primary producers in a terrestrial food chain are going to be your plants. They're able to secure the energy from the sun, photosynthesize. In an aquatic food chain, a marine food chain, what you basically have, they're called phytoplankton. They're single-celled little floating organisms that photosynthesize, and so they are your primary producers in your marine food chain. You then have your herbivores, which eat the plants, your carnivores, which eat the herbivores. So we have primary consumers and secondary consumers, tertiary consumers, which are going to eat the carnivores that eat the herbivores. And you even have quaternary consumers, the carnivores that eat the carnivores that eat the carnivores that eat the herbivores that eat the plants. If you wind up having some sort of a change in a community assemblage, again, this is really important. Community ecologists need to understand the food web, food chain within their given geographic area in case you happen to fall short in any given level of the food chain. If you wind up having, oh, sorry. It's unexpected. Excuse me, just yawned. If you wind up losing your rodent population, that's a really important bite-sized meal for the tertiary consumers. And so you may not have them be able to survive in any given area. Without your tertiary consumer, you may not be able to have your quaternary consumer. And so it's also important in understanding, which we'll discuss a bit in conservation ecology, but we already visited it in geographic range as far as. Hold on, sorry. All right, if she keeps screaming, I'll have to move off my sofa. I lost that train of thought. Dang it. If you have, um, shoot, if you're missing the rodent, missing the bite-sized meal, you're not going to have your carnivores. Well, I guess I'll have to get back to that. That you must have a robust representation of every level of the food chain and the food web in order for there to continue the degree of biodiversity in your particular geographic area. So then we can dive a little bit deeper as far as who's eating who. So who is eating who in your community dynamic? Well, we have a term that I think many of you are familiar with. It's referred to as predation. That is something eating something else. Mostly this is an animal phenomenon, but you do have plants that are involved in some of these terms as well. And obviously, in predation, you have one population that benefits and one that absolutely doesn't. It is obviously very negative if you're the one getting eaten, and positive if you're the one that eats. You have true predators, which consume the entire animal. The prey would be considered, or a plant. They eat their prey or all of it. They kill it. Whereas grazers, they only harm the prey, but they really don't kill it. Now you can have animal grazing on an animal as well, so you do have some back and forth as far as these terms are concerned. It's not just an animal eating grass, for instance, like you see the sheep here, but you also have like a tick feeding off of a dog. That it would be considered a type of a predator, but a grazing predator. Different types of these trophic relationships. Parasites are those grazers, those predators as grazers that feed off of their host, their prey, but it's not their aim to kill their host. I mean, generally when you think of parasites, it's a negative thing. They're nasty, they're gross, they're and I guess unscientifically, I suppose that they are, but their job isn't to kill their host, because if they did, then they themselves would die. So they don't want to kill their host. They're just feeding off of it. And they could be ectoparasites, for instance, skin parasites live on the outside of the plant or animal, or endoparasites. They live in the intestines, or they live in the liver, or they live in the brain, or they live in muscle tissue. And they can go from, or I should say that they are generally passed from host to host. Sometimes it's a fecal to oral transmission, or the eggs are shed in feces, like in an aquatic ecosystem. Snails are commonly intermediate hosts. My gosh, if you're out in the wild, please don't eat a raw snail. They carry they're intermediate hosts for so many parasites. If you're going to eat a snail, please cook it. And it's to be said that out in the wild, that, again, not using absolutes, but 99.99% of animals that live in the wild all have parasites of some sort, and they have evolved to species specifically to live inside or on those parasites. And for the most part, unless the animal or plant is immunocompromised or under a severe amount of stress, they are fine. They've just evolved to have parasites. If the animal becomes immunocompromised, sometimes what can happen is you would wind up with the parasites taking over and then killing the host, but that isn't what the parasite wants to do. And it's really interesting because it escapes me which type of white blood cell is responsible for keeping parasite loads in check. But animals have a certain type of white blood cell. They have different types of white blood cells, and there is one that is specifically there to keep parasite loads in check. And we as humans still have these types of white blood cells, but humans really don't have parasites anymore. We used to a long time ago, and so it gave this type of white blood cell something to do, right? And now that we don't have parasites, these white blood cells are kind of still hanging around, but twiddling their thumbs with nothing to do. And it is hypothesized that that's why humans over the last 100 years have developed so many allergic responses, because these white blood cells that used to have this awesome job fighting parasites are bored, and they're going after other things in our body, and they're causing all sorts of deficiency types of problems. And that's kind of interesting, actually. Parasitoids, these are actually parasites that, yeah, they'll eventually kill the host because they don't live forever on it. And like you often see these caterpillars with the wasp eggs on the back, they're going to kill that host, and that's very unsettling, but nonetheless. But you do have adaptations of hosts, those adaptations that have evolved as a result of living with parasites to keep those numbers in check, not just a robust immune system with the type of white blood cell that is escaping me that keeps those numbers in check. But grooming, you can have a behavioral adaptation of group grooming where individuals groom each other and pick like ticks and fleas off of one another and lice. A scratching to help remove parasites, external parasites. Seeking shade as far as cooling the body down so parasites, they're not as favorable to some parasites. Some inflammatory responses, like here's a plant that forms a gall around a parasite. You have your immune system, the cyst formation, gall formation, that is there. Like cysts, especially like in muscle tissue, it like often with pigs, they saw this, that you had a type of parasite that inhabited the meat and you would have a cyst form around it, so to try to isolate it so it doesn't breed and get out of control. Hind beaver foot, this is really cool. Why is this here in this discussion? It's because they have very specialized adaptation of grooming claws on their back feet. They're double, it's hard to see here, but they're double clawed toes that acts almost like a fine-toothed comb that catches external parasites to remove them. Evolution is cool. That's a very specific evolutionary response to parasites in beaver fur. That's pretty neat. And obviously, if you're a predator, you want to be able to catch your food more efficiently. If you're a prey animal, you don't care to be captured, right, and eaten. You do not want to be somebody's lunch. And whereas, let me just check this. Okay, whereas if you're a predator, you might have really, really good eyesight, or you might have very sharp teeth, or you might have very sharp claws in order to catch your food better. As a prey animal, you have all sorts of different types. Sorry, that's the a fan. I'm gonna kind of move. My son just walked in the door. There we go. You have some traits that keep you from being from someone's lunch. These evolved adaptations in order to keep you from being eaten. You can have those features that are fixed, a constitutive trait, that is, coloration or a turtle shell, or an induced trait that is something that in the face of danger, it is exploited, like some sort of alarm call or the spraying of a skunk. There are chemical defenses, so you can be stinky or release a stench or acidic compound like a skunk to keep predators away. And of course, that's an induced trait. Some snakes are venomous. Sometimes that keeps their predators away. It's actually meant to to catch their prey, immobilize their prey, but that can also be used as a defense mechanism. You have some turtles and snakes that emit a noxious smell out of their back ends. It's like stink pot turtles do this. It's why they're called stink pots. They're known as musk turtles. And it's kind of like if you're a predator and you put a musk turtle in your mouth, it releases this musk and then the animal is disgusted by it and then drops it. If you went to eat your peanut butter and jelly sandwich and it emitted musk, you would probably spit it out. So that's how that works. There are also physical defenses. You have those physical defenses like the armor on an armadillo or spikes on a hedgehog. A tough meal to swallow. This poor fella here, oh dear. This is a dog that tangled a little too closely. That's his face with a porcupine. That's definitely nature says no. Um, the shell of a turtle, of course. You can have warning coloration. Skunks not only have a chemical defense, but those stripes warn predators that they are not a good choice in a meal. I can never read aposematism. Yeah, see, how many years have I been doing this? I've been in ecology for 30 years and I don't know how to pronounce that word, never have. But this is a snake, red against black, you're okay, Jack. Red against yellow, you're a dead fellow. Yep, red against yellow. There you go. That is a coral snake, a venomous snake, and that is nature's warning coloration to say, I think you should keep moving along and not eat me. Now, there are also behavioral defenses that have evolved in common prey animals to limit their chances of being eaten. If you live in a flock or a herd of a lot of individuals, the odds are you won't be the one that's eaten. That's the behavioral defense. Sometimes what you have in these big flocks or herds or groups of animals, you have a sentinel, somebody who keeps an eye out. Like here's a meerkat. That's the one who's looking out for the rest of the other meerkats. Or if you more closer to home, if you ever see a flock of Canada geese feeding on a lawn, generally there's at least one that is keeping an eye out, has his or her head up, looking around. And when that goose puts their head down to eat, somebody else puts their head up. And when there is danger, they have alarm calls. They warn everyone, and definitely that confuses a predator, can scare a predator off. If you are into birding, you might know, or if you didn't know, you know now, that birds have different calls. I mean, sometimes they'll just call, just sing. And birds have different songs, of course, but they do all have, or most have, a unique sound or call that they make, an alarm call, as a warning call to other birds. And that is an evolutionary defense against warning their friends as far as predation is concerned. Let's give a shout out to the plants. Of course, there are different modes here of or I should say different adaptations that plants have. They don't want to get eaten either, and so they have different types of defenses. They have physical or mechanical defenses too. That spikes and thorns, absolutely, you don't want to, or most animals, some have adaptations that allow them to eat thorns and spikes, but you don't want to mess too much with these. We do have lots of plants around here that have these features, these spikes and spines. This is really specific. This is a sensitive fern or sensitive plant. And if you touch it, it instantly curls up. It's really neat. Like you rub the base of the leaves and it just like falls over. It's very cool. And that is a defense mechanism because if an animal goes to eat it, like rubs up against it, it falls over like it's dead, and then the animal won't eat it. Now, traditionally, these clever plants have evolved these adaptations, these chemical defenses, whether it is some sort of really nasty scent or they might taste bad. Now, from a culinary standpoint, we've learned to harness this. Where as much as we might like oregano and basil and mint, wild stock plants have evolved these traits in order to not get eaten. Now we've selectively bred the wild stock to enhance some of these flavors, actually. So So like what grows in the wild might not be as strong, but nonetheless, it does keep animals away. You don't, if you live in an area that has lots of deer, for instance, generally they'll leave your herb garden alone because they don't like the taste or the smell of those plants. But you can also have toxins, poisonous berries or compounds that are found naturally in plants, like nicotine, caffeine, cocaine, morphine, mescaline, pyrethrins. These are natural compounds found in plants. Now, again, with many of these wild plants, we have learned to selectively breed these plants to enhance some of these effects. Even like marijuana, the THC content. They say that your grandparents' marijuana from the 60s is a whole lot weaker than what they have available today because of selective breeding. But if you're an animal out in the wild, and you have eaten a cocaine plant, hold on, Isaac, I'm talking. I'm sorry. Thank you. All right, I'll be done in like 5 minutes. Okay? Don't say it. I'm already talking about marijuana and cocaine, so I mean whatever you say. But I have to keep talking. I'm still lecturing. It's about plant adaptations. But if you're an animal and you eat, coffee plants, you'll remember that. And chances are, if you get that rush, you're not going to eat one anytime soon. Eat something with mescaline in it. Good Lord, you're going to trip, and you're definitely not going to eat that again. There's some really very interesting adaptations of animals living in a community. These are evolutionary adaptations, and we could spend so much time on these because they are just fascinating. And that is the concept of mimicry. And mimicry has evolved. So again, in response to predation, you don't want to be eaten. And so you have evolved to have these particular strategies. And mimicry is where you have a species that just simply looks like another living species. You resemble another species in order to keep from being eaten. Bayesian mimicry is where you have like one particular trait and one kind of bad guy, and you wind up having lots of animals that have evolved to look like this bad guy and afford the same protection. And the classic example is a yellow jacket. They are just nasty and aggressive, and they have this yellow stripy pattern, yellow and black stripes. And you have lots of different insects that live in the same community as yellow jackets that have evolved to have these stripes as well, but they're harmless. They don't sting and they're not aggressive, but the black and yellow stripes keep a lot of other animals away. Malarian mimicry is where you wind up having just kind of an overall trait, like harmful or warning coloration across species. Like for instance, the yellow. Ooh, that was my bass guitar. Yikes! Like bright coloration or stripes, like amongst you see there the frog and here and the eft, as well as a monarch butterfly, which signal that it doesn't taste good or is poisonous. So that is referred to as Malarian mimicry. These are great videos, by the way. I don't think I showed them for your learning activity, but I recommend you take a look. Bless you. Camouflage is mimicry of the environment so they can blend in. And fascinating from an evolutionary standpoint. You can be camouflaged as a predator, so you are more efficient in hiding and jump scaring your prey. But we see this a lot in prey animals to hide so they're not eaten. For instance, here is a predator. It's a little covered up. Here's a predator that is camouflaged. There we go. It's a praying mantis, and it's camouflaged in this specific orchid. Actually, it's an orchid mantis, and it is waiting for an insect to come by so it can snatch it. And here's its arms and its head and its body, and it's colored just like that orchid. And that's a predator that is camouflaged, so it can find its food. This is totally cool. I mean, all of these are cool. And there's, again, I recommend you watch the videos, have the montages there. This is a type of I believe it's a mantis, and it is camouflaged. There we go. To avoid predation by looking like a pile of leaves. Here are its arms, that's its back end, its abdomen, and its thorax. And it didn't put leaves on itself. It actually has camouflaged, evolved to look just like leaves. It includes the veins. It includes even little chew marks. So it kind of looks like leaves that are beaten up a little bit, and is often overlooked by predators and is safe in that way. A bird is camouflaged here. These owls are camouflaged. Those are predators that are camouflaged, but also camouflaged so they themselves don't get eaten. Whoops, sorry, where'd we go? This is a young marsh bird that has a striped neck, and when it holds its neck up in the air, it camouflages with the reeds behind it. And I had to include this, of course. And again, if you watch these montages, there are just so many fascinating examples. This is my nephew. There he is, and he's camouflaged to his sheets. I guess there were monsters in his closet. So he wore pajamas that look just like his sheets. There he is. Here are his sheets. You could just see his head right there. Anyway, I thought that was very cute. I can do that because I'm the teacher. Put in pictures of my relatives and such. So those are relationships among our evolutionary relationships that are set up as responses to predation, as far as predators and prey. You have different types of mimicry, as well as the camouflage, which is just mimicry of the surroundings to blend in with the environment. But there are non-trophic relationships, symbiotic relationships, which are a result of populations living together in any given community, and they don't involve eating one another. Commensalism is a relationship, a symbiotic relationship, where you have one species that benefits, and the other species involved isn't harmed or isn't helped. The classic example is a bird that builds a nest in a tree. Now, not all birds build nests in trees, but many of them do. And when you have a bird building a nest in a tree, it is a relationship between the tree and the bird, two different living organisms. Now, that benefits the bird because it keeps the nest off the ground. It keeps the nest away from predators. Does it benefit the tree? No, there's no benefit to the tree. Does it harm the tree? No, it doesn't harm the tree. And that's why you see a zero. A zero indicates the neutral relationship, as far as, the plus is the bird benefits, but the tree is neither harmed nor is it helped with that particular relationship. And we do see a lot of this out in nature. You also have symbiotic relationships where both benefit. We refer to this as mutualism. Now, in mutualism, you can have relationships that are obligate or facultative. And obligate relationships are where neither can live without the other. You wind up, in many cases, you wind up having them inhabiting the same structure. They're two different species, but they actually live together. Like, for instance, you have coral. Is that going to show up? Yep, there we go. You have a coral polyp, the zooanthele, and then the coral itself, the polyp itself. If you lose one of those species, neither of them can survive. You have a symbiotic relationship, an obligate symbiotic relationship between fungus and algae. It's called lichen. You see it growing on the sides of trees as well as on bare rocks. And the lichen, the fungal species in that relationship, it provides the structure for the algae, and the algae provides nutrients for the fungus. And if one of those dies, then the entire structure dies. More so, what we see is facultative mutualism, and that is that both species benefit, but they don't depend upon each other solely for their survival. For instance, this is a cow, and it has an egret standing on its back. You see that a lot. That is a mutualistic relationship, mutualism. Now, how does it benefit the bird? Well, the bird is eating the ticks off of the cow, the parasite, so the bird eats. The cow is benefiting because it gets parasites bitten or eaten off of them, so that's good too. But will the cow die if the bird doesn't show up? No, the cow isn't going to die. Will the bird starve without the cow? No, it'll just eat something else. And so therefore, where it benefits both involved, it is not necessary or critical for their survival. So very fascinating subject. If you're a community ecologist, this is like really, really cool to study. Now, again, there are video clips here. You can watch those at your leisure. But different types of relationships we covered here. When living in a community, we have food webs and food chains, parasitism, predation, different types of evolutionary traits that keep predators or prey from being eaten, allow predators to be more efficient predators, plant evolutionary responses to predation in plants, different types of mimicry and camouflage, and different types of symbiotic relationships. Hope you enjoyed the lecture. Please, if you have any questions, let me know. And I hope you have a good rest of your day. Take care. Bye.